Yeah, it's a pleasure to meet in our second examination type question, and which is actually going to prepare ourselves for a practice in our examination questions, which we are going to encounter a few months to come. So now let us actually see on the question which we have here, which is written as question number 10. It says lead acid batteries have been used in cars for the past 85 years. The equations of the half reactions that take place in each cell of such batteries are shown below. We have lead solids plus hydrogen sulfate ion. Then we have the formation of lead sulfates plus the hydrogen ion plus 2 electrons. As we can see here, we have the formation of some electrons, which means to say that we have a loss of electrons in this particular reaction. So this one, it's an oxidation reaction, right? If we're going to look, which means if it is an oxidation reaction, it actually occurs at the anode. Right, that is the anode of our battery. So if we go to our lead oxide, the second equation, in which we have our lead oxide solid plus 3H plus hydrogen sulfate ion plus 2 electrons, we have the formation of lead sulfate as well as water in liquid form. Right, as you can see there, we are adding electrons. So at the end of the day, this one is a reduction reaction, because we know that reduction itself is the addition of electrons, right? So this particular equation occurs at the cathode. Why? Because we know that our batteries themselves, they are a collection of galvanic cells, and these galvanic cells themselves, they convert chemical energy into electrical energy. So now let us look on question number 10.1. It says write down the oxidation number of lead in lead sulfates. What we are supposed to know is what is an oxidation number. An oxidation number is the charge which we have on our atom. So atoms themselves, they are chemically neutral, and as a result, they are being given an oxidation number of 0. But if we are going to go to our lead sulfate there, let us see what's happening in our lead sulfate. So as we can see on our question 10.1, right, what we have is that we have lead sulfate. In this particular lead sulfate, we know that the sulfate ion itself is a polyatomic ion, which has an overall oxidation number of 2-, or it has an overall charge of -2, as you can see there. So, but now we know that compounds themselves are chemically neutral, which means to say that their overall charge itself is equal to 0. So consequently here, our lead is supposed to have a charge of +2, so that if we're going to add +2 and our -2 there, we are going to get a 0. So all what it means is our lead here is an oxidation number of +2. So that is our answer to question 10.1. Let's go to question 10.2. It says that write down the balanced equation for the net cell reaction. As you can see in these particular equations of reactions, there is need for us to balance our electrons so that we can balance our chemical reaction, and we are going to find our overall reaction. So since we are losing 2 electrons, and these 2 electrons are the ones which are being gained by our second half reaction, so there is only a need for us to actually balance, to actually add the substances which we have here. So we are going to have our lead solids plus our lead oxide solids, right? We have our hydrogen sulfate there, plus our hydrogen sulfate. We're going to have 2 hydrogen sulfate ions plus 3 hydrogen ion, but right there on the right hand side we're having the hydrogen ion, and if we're going to put it this side, we're going to have 2 hydrogen ions, and then here we are going to add this. We're going to have the formation of 2 lead sulfates, and consequently we're going to have the production of 2 moles of water. So now if we go to our question 10.2, if we add them, we are going to have our lead, which is in solid form, plus our lead oxide in solid form, plus our 2H plus our 2 hydrogen sulfate ion, right? And this one is in aqueous form, like the hydrogen ion also is in aqueous form. And what are we going to form? We are going to form 2 molecules of 2 moles of sulfates, lead sulfates in solid form, plus 2 moles of water. So that is what we are going to have. This one is our overall reaction. But 2H plus 2H SO4, this one, if we're going to add 2H plus in aqueous form plus 2 hydrogen sulfate, right, ion in aqueous form, these ones are going to give us sulfuric acid, right? So these ones will give us sulfuric acid. So we can even replace these ones with sulfuric acid. So, or we can get our lead sulfate plus our lead oxide in solid form plus our sulfuric acid also in aqueous form. We are going to get 2 lead sulfate, right? That is our 2 lead sulfate there, plus our 2 moles of water, right? So that is what we have. We can have this particular equation or this one, any of the two, they are going to give us the correct answer. Let us proceed to the next question, right? So now if we're going to proceed on to question 10.3, it says which one of the reactants is the reducing agent in this cell reaction? Give a reason for the answer, right? What we want is a reducing agent. The definition of a reducing agent is the one which is important here. A reducing agent is a substance that causes the reduction of another substance, but it is itself oxidized in the course of the reaction. So we are going to identify our reducing agent